I bring you greetings from the Victory Christian College, Port Harcourt, Rivers State. In this lesson video, we intend to introduce us to concept of pressure. It's a physics lesson, and stay tuned as we take the lesson.
Okay guys, our topic for today is concept of pressure. We should all be wondering what pressure is. So here, pressure is defined as the perpendicular force unit area acting on a surface. The force and area are involved in the definition of pressure, but that force must act perpendicularly to the area under consideration. This definition tells us that if the force acting on a surface area is not perpendicular to the area, if the force is not perpendicular to the area, it cannot be considered as pressure. And this definition also shows that pressure works hand in hand with force. Without a force acting on a particular object or area, there is no pressure on that particular area. Symbolically, we can write pressure as P equals to F over A, where P is pressure, F is force, and A is area. So, since force is measured in newtons and area is measured in square meters, the SI unit for pressure is Newton per square meter, which is the combination of both the SI unit for force and that of area. And another unit for pressure is Pascal. Pressure is called a scalar quantity. Why is pressure a scalar quantity? Pressure is a scalar quantity because it has magnitude but no direction. Now we'll be looking at factors affecting pressure. First, since pressure is dependent on the area over which the force is acting, the pressure can be increased and decreased without any change in the force. That factor is telling us that you can increase the pressure acting on a particular surface area without making any changes to the force. This can be done by either increasing or reducing the surface area upon which that pressure is being acted on. Secondly, the force applied is said to be constant. If the surface area becomes smaller, the pressure increases and vice versa. For example, a brick sitting on a surface exerts a force that's equal to its weight on the object it is resting on. This can be illustrated by a simple sample of acting, let's say, 10 Pascal on a surface area of 400 meters, and then the force is still constant. If the area is reduced to 200 meters and you're still acting the same force, the pressure increases because there's more force on a smaller surface area. Thirdly, we have that a rectangular brick has a wide surface area on the sides, and by changing the orientation of the brick resting on the surface, we are effectively changing the pressure acting on the surface by the same brick, as I earlier explained. In other words, if the surface area becomes smaller, the pressure becomes higher because the force is constant. It is for these reasons our knives and nails are sharp, because the sharper the edge, the higher the pressure. When we have a sharp knife, our knife has two sides. If you apply force with the blunt part of the knife, cutting through that particular object is going to be very tough and almost impossible because that part is blunt. And if you apply that same force with the sharp edge of the knife, it is way easier because the pressure is not, you don't need too much force because that part is sharp, making the whole stuff easier. we are going to be taking some solvings on pressure. Like we earlier said, pressure can be calculated using the equation P equals to F over A. So for our first example, we have calculate the pressure exerted on the ground by a person weighing 70 kg, whose 2 feet cover an area of 400 centimeters square. If the man stands on 1 foot, what is the new pressure to be exerted on the ground? So we have P equals to F over A, where P is pressure, F is force, and A is area. Force equals to mg, which is mass times gravity, and then the N there stands for Newton, which is going to be the SI units for force. And according to our question, the mass there is 70 kg and the constant for gravity is 10 meters per second. So we have 70 times 10 newtons, which gives us 700 newtons to be our force. Area is equal to 400 centimeters square as regarding our question, and we can solve with this in centimeters because the SI unit for area is in meters. So we convert 400 centimeters to meters, which gives us 0.04 meters square. And then we have P equals to force over area, and which gives us 700 divided by 0.04, and that gives us 17,500, or 17.5 times 10 raised to power 3 newtons per meter square. That's putting the equation in a standard form. And if the person stands on a foot, which means the area has been reduced, and then the area has been reduced and the force is constant. So we have the area being divided into two. From 0.04 we have 0.02, and we divide by the same 700, which we have as our force, and we'll notice that whatever we get from that answer, from that equation, is going to be twice as much as this. Why? Because of what I earlier explained, whereby when the area is reduced, the pressure increases, and vice versa. We'll be going to pressure in fluids or liquids. Unlike solids, which exert pressure in one direction, that is downwards, liquids exert pressure in all directions. This means that in solids, when there's a pressure on solids, the pressure in solids always goes downwards. But in liquid, let's say we have water in a bottle, the pressure is exerted in all areas around that container, not only in one direction there. We have some characteristics of liquid pressure, and first we have the pressure at all points at the same level within a liquid is the same. This means that in a bottle of water, the pressure from the top of the bottle to the bottom is the same. The pressure doesn't change as long as it's on the same level in the container. Secondly, we have the pressure in a liquid increases in direct proportion to the depth of the liquid, meaning that the deeper the liquid is, the more pressure is on that place. This can be shown in this diagram here, where we have a beaker holding water with 3 punctures in it. We have A, B, and C. As we can see, there's more water coming out from the hole C. This is because as the depth increases, the pressure increases, and hole C is close to the bottom of the beaker, which shows that there's more pressure down there, and that's why we have more water coming out from hole C. The water coming out from hole B is greater than that of hole A because it is deeper than that. So that shows that the pressure increases with depth. Thirdly, we have that the pressure in different liquids at the same depth varies with the density. We'll be going to deriving the formula of pressure in fluids, and let's see how we go through that.
Okay, so we will be deriving the formula for pressure in fluids. That is derivation of formula for pressure in fluids, where we have volume of cylinder of liquid as area times height, and the mass of liquid, which equals to volume times P, which is density. Therefore, we have the mass of liquid as area times height times density, which is P. And then we have the base of liquid as area times height times density times acceleration due to gravity, which will be given as G. Therefore, the pressure, which is P, is equals to force over area, which is equals to the weight of liquid, which is area times height times density times acceleration due to gravity divided by area. Now, deriving the formula, we have P over 1 times weight of liquid divided by area. Now, we'll be making P the subject of formula, where we cross multiply and cancel out by the area, where we have P equals to height times density times acceleration due to gravity. Now we'll be calculating one example. Calculate the pressure of water at the bottom of a drum 200 meter deep if the density of the water is 10,000 kilograms. Take G, acceleration due to gravity, as 10 meter per square. So earlier we made P subject of formula, which is height times density times acceleration due to gravity, where we have P equals to height, which is 200 meters deep. Therefore, we have P 200 meter times density, which is 1,000 kilograms. We'll be showing our answer in standard form, which is 10 raised to power 3 times acceleration due to gravity, which is 10. Therefore, P equals to 2 times, due to the laws of indices, we have 2 times 10 raised to power 2 times 10 raised to power 3 times 10. And also, due to the laws of indices, we have P equals to 2 times 10. When there is multiplication, you add up the index, so 10 raised to power 2 plus 3 plus 1. Therefore, we have P as 2 times 10 raised to power 6 Newton per meter square.
Okay, we come to the end of the lesson for today. We want to thank you for your time in taking this lesson, and we encourage you also to subscribe to our channel, even as we expect more lessons coming up. Up next, we are going to be discussing in these lessons pressure in the atmosphere, which is same as the atmospheric pressure. Now, to summarize what we've talked about today, we want to look at basic things that was discussed. First of all, if we define liquids, haven't discussed pressure in liquids. What is liquid then? Liquid can be defined as any substance that takes the shape of its container. Next, we are going to be looking at gas. And let us go with this question. Do gas also behave like liquid? If we say liquid takes the pressure, the shape of a container, we are also going to see that in the lesson as we talk about atmospheric pressure. Thank you, and God bless you all. Stay tuned.